A very good evening, ladies and gentlemen, boys and girls. I'm really thrilled to be here amongst all of you today. First of all, how are you all doing today? Yeah? Wonderful, wonderful. So, thank you so much. First of all, I would like to thank the committee for having given me this opportunity to be here to share our experience with all of you and probably make your next 30 minutes a little useful for you to carry forward some message from here. Yeah? So I'm Bhavya from a company called Bhavya Shetty. So we are a construction company, contractors mainly, which we are in existence for nearly 50 years now. And in the last 10 years, predominantly we worked with different technologies in construction, especially for mass housing sector. And that is what I'm going to be talking to you today about. So we are a third generation company. We have built nearly 2 million square foot and above just mass housing projects for a lot of private and government entities, especially in Karnataka. So before I get into the technology that we have adopted and the technicalities of what we do, I would like to just give you a perspective of how did we start off on this journey of getting into mass housing. So you see, India is a highly populated country like China. We both are like really populated. Probably we will also, go ahead of China very soon. So with that kind of population, initially, let's say 20 to 30 years back, most of our population was concentrated in rural areas, even up to 50 years back. But now, the population is moving to urban areas, metro cities, in search of better life, quality life, in search of better work options, better salaries, better lifestyle in the sense. So if you just look at it, as on this year, our 34% of population in India is concentrated in urban alone, right? And it is going to reach 40% in next probably 7 years, which is 2030. It will be 40% of our population will be only in urban areas all over the country. So this is quite a serious problem, and whenever there's a problem which the society has to deal with, we civil engineers have to think for another 10 to 20 years ahead, where we start using technologies, which is the only answer, where we can probably maximize our efficiency in delivering what is required in our society. So with this, and it's also estimated by 2030 we will be needing nearly 25 million houses. And can you imagine these being built brick by brick with 1,000, 2,000, 3,000 people in one project site? No, we need something which can make us more effective, more efficient, more faster, more cost effective. So to address mass housing, of course, there's a lot of challenges which needs to be looked into to make it viable for everyone, the entire mass housing market. And out of this, some of them are affordability. How affordable is the technology that we're going to use? How fast track can we make it? And also we have to deal with shortage of skilled labor. See, having the kind of labor, the volume of labor we need in India is not a problem. But the kind of skill we need in these people is where we lack right now. Because all the construction workers want to now migrate into something else to get better lifestyle, to get better jobs. So they are dropping, and also with government coming with a lot of, let's say, 1 rupee a kg of rice. Schemes, a lot of people, especially construction workers, do not want to work anymore. So that skill, like I said, is getting diminished. So, and of course, for a mass housing project, land and acquisition costs, regulatory approvals, and funding. So these are some of the challenges we need to address when we go for what kind of technology or what we have to address for mass housing. And in this, the top 3 are the ones which a civil engineer can address. But the bottom 3, we definitely need all the stakeholders to be a part of it. Government, private entities, everyone could be a part of that. But let's see, as a civil engineer, what we can do. Right? Why fast track technology? I think we have heard enough and more from yesterday of different technologies being used and the advantages of these technologies and why exactly we should move out of it, out of our traditional way of doing things to a more efficient way of doing things, right? Of course, speed is something that we need. 25 million houses in next 7 years is not a joke. And cost effectiveness, yes, with every technology, the more for a country like India, cost is very sensitive matter which needs to be dealt with, and we have to find out a technology which can fit into the cost. And technology should be such a way that, like a lot of them already told, standardization and scalability is another important point, where whatever you come out with, whatever option you want to adopt, because there's so many technologies available in market today, is it scalable, right? And is it something where you can put a process and probably it can run like a assembly line, like any manufacturing unit, maybe a car manufacturing unit, something like that. So, of course, and with any technology that you're going to think about, see, one thing we all know, future is about tech, irrespective of whichever industry that is. And any technology that you think of should also be able to integrate with a lot of other technologies which is going to come up, right? So our journey with technology, so we have been in existence since 1964. Like I said, we've done a lot of traditional construction from, from variety of industries, monasteries, temples, Talkavi temple, a lot of it. But it was 2010 when we really got into mass housing, usage of different technologies. So 2010 is when we started using monolithic construction, using aluminum formwork system. And then 2014 is when we started precast construction for buildings, especially mass housing. And then we've also been experimenting lately with EPS panel technology. Of course, it's in a trials session, but probably we'll talk about it some other session. So monolithic concrete. So monolithic concrete is basically a custom place, a monolithic structure completely made of one element, which is concrete, right? So how did the word origin? It's a Greek word, mainly monos and lithos, which only means single stone. So that's how the word monolithic came into existence for our civil engineers. So anything which was made of one element, one material, one homogeneous material was called a monolithic structure. And these monolithic structures, the monoliths which have been in existence, have stood the test of time for probably thousands of years so far, right? That's because the moment a lot of material comes into a structure, the moment heterogeneity comes into a structure, the problems start creeping up slowly, steadily over time. So the moment you make the structure out of one element, your problems are already less in a structure. From the perspective of construction, from the perspective of maintenance, from the perspective of durability also. So, a single material in today's generation, we can only link to concrete. Why concrete? Because concrete is the oldest man-made material, the only very versatile, highly tested material which is in existence, and like Nagesh sir already told, concrete will never let down in civil engineering. Okay. So I'll just show you a clip of the process of monolithic construction. So you can do a raft or strip footing, and as soon as that is done, each floor you lay down your welded mesh or your rebar, and then you start fixing your formwork. So these are the tie rods which are holding the formwork together. This is an aluminium formwork system, which is a self-leveling, self-aligning system, which I'm sure you've probably seen abundantly in Bangalore skylines today. So all your openings, everything, including your door, windows, all that will cut out, will be left, and the openings will be made. And then ties for your opening not to bulge when you concrete, and the slabs and everything will be started to lay down. And then we usually use a boom placer, and it will be completely concreted, the entire structure, your walls, beams, your cheddas, your parapets, whatever element there is in structure will be concreted completely in one go, with of course a self-compacting concrete. Right? And within 12 hours we also de-shutter the walls, and then slabs probably in around 16 to 20 hours with central support in place, of course. And then all the tie rods are removed, and then you prepare the platform to ensure complete safety of the people working on the next floor ahead. And those black ones are the tie rods which holds your system together when you concrete to keep it in place. We were the first to also introduce this to the government agency and then show them that the entire house, including wall, slab and all the elements, could be cast in one go. Until then we were all casting it wall separate and then the slab and then probably the elements. So we were the first to do a single pour for the entire structure. So this is our initial days where a lot of mass housing was done, nearly 3,000 houses for different government agencies, and including the foundations were done in monolithic strip wall footing system. And then that is the aluminium formwork. Like you can see, we have a row of houses. Every floor plate is around 2,000 square foot of 4 houses. And each square plate, every 4 houses were being concreted every 48 hours. That is the kind of speed which we could achieve in this project. This was way back in 2011-12. That was the first project for Slum Development Board, and also we worked for police housing. Like you can see, this a single row will have a 64 units of G+3 building, and we could finish this entire structure in a matter of 1 month. And of course, no plastering done. And this is the interiors of these houses, and these are the government houses. And we've heard enough, I think, advantages of technologies, especially precast and monolithic in some way. Yes, the only difference with monolithic and precast is the entire unit is cast at site with a self-compacting concrete, whereas in precast, it's completely manufactured at factory and assembled at site. So of course, your time, your cost effective, absolutely the plastering, most time consuming and really an activity which involves a lot of wastage in construction is plastering, and that is completely avoided. And I would say with every technology, there is some limitations which we need to work with. And if you're able to choose the right technology for the right project, you should be able to overcome these, cons also. So of course, there is some limited on-site modifications that you could do. But if you can design it well ahead, those things also can be thought of. And this monolithic especially also needs to some extent a little bit of skilled labor which we need to train on, and initial cost compared to a conventional construction, if you say, would be a little high. And this technology will be mostly suitable for a shear wall structure which is usually in a modular residential buildings. Right, so like I said, we were the first to demonstrate for a slum board in 2010 where we could cast the entire structure in one go, and we were also given by Ministry of Housing most cost-effective housing technology award. So that was one of the technology that we worked with for nearly 7-8 years, and since 2014 we have also been working on precast. So with monolithic, yes, we were good. We were able to match the price after couple of projects. We were able to get the speed of the project also, but still we had to deal with transporting concrete, because concrete is a very time sensitive material, we all know, right? We have a time gap by which we have to pour it, we have put it in the final shape. So the more remote the place, the more problems were cropping up, and to ensure the weather doesn't affect my production, whether I consistently get whatever I get in the first pour, the surface finish was becoming a little difficult the moment it went outer and outer, and the moment the distance from the the central where the concrete was produced was becoming more. So with that, when we started exploring what other technology can we move on to, is when we got on precast, we studied and then we started using it. So I'll also run a video for you so that you understand the process that we follow. So yes, so precast, like I said, all your elements will be manufactured in a factory, transported to site, and then will be erected. And then this needs heavy machineries, of course, when you have a volume and when you need the speed that you need, and the speed in precast is definitely more better than the speed you get even in monolithic construction. So these are wall panels being joined and then slab, and then all the joints, which I will show you ahead, will be grouted. So as soon as the ground floor are completed, you immediately can start painting and fixing all your open joineries. And this is one of the projects that we also did in Mysore recently for Tata Motors, where it was not a housing project but also a commercial project that we did in 60 days. So this is a setup of casting yard, where we pour all our precast panels will be 2D cast on a plane and then finished. So like you can see, from the day 1 we started production, at the day 10 we were already through with our. So simultaneously, when your foundation is started at the factory site, your factory activities will also be running. That's where we save time. And these panels are being transported to site. So all the wall panels will be transported vertically on an A-frame. And all kind of elements, including your frame structure, can also be precasted. So this structure especially had both shear wall, your solid precast slab, your column beams, and cantilevered slabs. So day 20 we were already through with the ground floor. So this is the bare shell, which had a combination of frame structure, which had a combination of shear walls. And they of course took some time for finishes, and this is the end product. And this is without plastering, the surface as it is. And we also got Outstanding Commercial Structure Award for this project. So this is a typical stockyard and a casting yard that we have. And this is also a mobile, completely knocked down stocking, casting yard. If there's enough volume, this entire setup can be shifted to any, let's say if you have 1,000 houses, 500 to 1,000 houses, if the land is also available, it can be completely shifted, manufactured, so that we bring down the cost of transportation altogether for bigger projects. So this is a typical stack yard that you see. And like we saw in the video, so this is where the start of the work happens, where we lay down your formwork and your rebar, and then you start your concreting, and then that's an A-frame trailer that I was talking about, where you mount all your vertical panels, your walls basically, will be transported on a A-frame and then erected at site using a crane. So typical mold and all the embedments in the mold you can see here. The complete reinforcement, including all your services, plumbing, your electrical, whatever embedments that needs to go into the concrete as per the consultants, will always be embed and then concreted. And also, like you can see, those aluminum tubes, those are the grouting tubes which form the connections from every wall from floor to floor. And then we concrete and finish the panel. This is a typical stack yard. As you can see, the walls and slabs, they're always transported vertically or horizontally. And every element will be labeled so that in a drawing it goes to the corresponding location that has been designated to. So this is a strength level car park, which is also done in the shear wall system itself. So after you place your entire walls, so also if you can see here, This is the foundation from which all your dowel bars are jutting out, at least a meter. So these are the dowel bars which form the connection to these walls, which will be grouted later. And then once the slab walls are erected, we have our precast slab which will be erected after that. So precast also, slabs can be done in many ways. One is half precast slab system, full precast, and of course, the hollow core system that we understood shortly. So in here, what we have tried is a half slab system, where half of the thickness of the slab will be precasted, erected, and all your electrical conduits and top reinforcement will be laid, and then the screeding is done. So this was also to ensure for Indian scenario, you do not have a horizontal joint in the entire slab, every slab, and you completely seal with the proper finished screed at site. So this is a typical wall-to-wall joints that we do. So these are called loop boxes. So basically these are, like I said, in a 2D precast panels, the panels, different elements come together and get joined, and these joints are designed so that the structure starts behaving monolithically. So these are wire loops which will be opened and locked on, and then will be completely filled with M60 grade grouts. And this is just a representation, a typical junction of wall and slab. Like I said, the yellow portion is the grout tube into which the dowel gets in, and then that will be completely grouted again with the free-flowing M60 grade grout, non-shrink grout. So this is a typical staircase, production that we do. Like you can see, the accuracy of the dimension that you see from the first casting to the 100th casting will also be the same. And this reduces your chipping and other works at site, which makes life easier for any construction civil engineer at site. And immediately after this, you can start working for your next activity of finishing. You don't even have to wait for another 2 days, 3 days, or even, a day. So yes, all the panels, your chajjas, everything will be precasted, erected, and then as you can see, the alignment of these buildings, that's the kind of accuracy that we can get, especially with precast, the precision that we get, especially the clean lines. Some canteen projects also we have done, nearly 48 canteens, and this is a security cable with an overhead tank that we have tried. And also this is another interesting project we did in collaboration with an Australian company. We started way back in 2012. And here, this was a mix of 2D and 3D precasting. This was done in Bangalore, near Alur for BDL. So here, all the panel elements were casted 2D, like a regular, plane system. And then at the factory itself, they were all fixed to form a cube, completely finished, including your tiling, your windows, your doors, your plumbing fittings, your electrical fittings, your painting, everything finished, each cube. And then transported to site, and then erected at site. Right? All the finish is done, all ready. The only thing left at the site is the welded connections which they had planned for this, for cube to cube to be joined, and the connections of your plumbing and electricals which have to be run through between each units. So this is another industrial project. So I'm just showcasing all this for you to get an idea that precast has no limitation. Any structure is possible, small or big. Right? So here, entire, including the foundations, column, beam, shear walls, everything was precast. You excavate, you lay the PCC, and then everything is from factory. This is another commercial complex where we did a hybrid because the design was already there and they started the foundation. It was actually a conventional building with flat slab, post-tensioning slab. So we said, okay, you carry forward with the regular post-tensioning design that you have, which we have already done. What we will do is, we'll add on to make it faster for you. The other elements that we can do, we'll convert into precast so that you get that time advantage instead of working with block work and plastering. So we completely did their retaining wall in 2 days because they had continuous ingress of water, which they were facing quite a lot of problem with. And of course, all the facade walls, like you can see on the other end, and even the lift, the staircase core and the staircases were all precasted. So this is a retaining wall that we designed, and in this retaining wall, the only surface we treated, we put a waterproofing, was for the joints, only the joints of the precast. We didn't have to do the waterproofing for the entire surface on the other side. And these, till today, it's been at least last, I think, 7-8 months, have not seen any dampness. These are facade walls, which will be hanged on to your main structure and bolted. So these are single 5-meter element compound walls that we did for cottage projects in Bangalore. So we were able to do 100 meters every day. And this is the Araskar showroom that we spoke about, Tata showroom. And different possibilities in precast, compounds, just plain compound with column and footing, compound monolithic just with the footing, compound with drain, compound with electrical, probably ducts underground. Whatever you want, there's just innumerable possibilities of combinations that you could do with precast. And whatever pattern that you need, on the surface. And this is a new, I would say, experiment that we're doing. This is for our own office project in Mysore. So we have just come out with a design along with architect and structural designer of modularizing a office building. So like you can see here, we have made modules of, like those white panels what you can see. We have made different modules, a module for a staircase, a module for probably a reception and open area, or a module for a workstation space, a module for a wet area. So we have done different modules. So what this does is it standardizes the module, and your width of your module can be changed as per the requirement of the designer. And here, all these can be also juggled like a Lego block. You don't want your reception at the entrance, you want the staircase, you just juggle it. Whatever you want to do in the design phase, you just keep moving with because there are standard modules, you just keep moving around with it and you come up with whatever design you want. This is an experiment that we are doing right now, and this is for our own office. Right? And in this, including complete foundation, we have made it precast. So you excavate, you put your PCC, and from there up, everything is going to be in precast. So in here also, we went one step ahead, not just precasting the entire structure, we're also making it knocked down. When I say knocked down, this is our office at the stockyard now. And if you want to move our factory somewhere, we don't want to leave our office behind. So our entire office is bolted net connection, completely precast, including your foundation, can go to a different city, different place, get erected, and completely start, operating within probably a week or two. So like you can see, these are the foundation elements being erected, and then including our grade slab is precast, so absolutely no PCC to be done at site. And all our walls are in precast. And in these modules, we've also made sure we give the flexibility of choosing different material on the other axis of the wall. You make it full wall, you make it brick wall, you make it full glazing, you make it half glazing, up to you. We give you modules, you work what you want. Right? So these are the walls being erected. Actually, this is the progress as on yesterday. So in these walls, like I said, it's all bolted, and nut and bolt connections. So in these walls, at the bottom, you might see small holes all along the wall. Those are the bolt nut connections, which typically looks like this. So yes, so precast, I think we've heard enough and more of the advantages that we're probably very well versed with precast by now, and it has already been stressed enough by all my other speakers around. So of course, but another 2 points I would like to further tell you guys would be a better working conditions at site. Can you imagine no water at site, no dust at site, an engineer coming, the kind of lifestyle or the kind of environment everyone, even the neighbor wouldn't know there's a construction happening next door. And the kind of wastage that we reduce here, absolutely no water for curing, completely chemically cured, and no plastering, and like I said, no maintenance. So yes, with the technology, there is still that challenge that we have. There are different technologies, like I said. We need to be able to select what is right for which solution. So some of the essentials of the technology which I could probably share, and different comparison of both the technologies, so that you're able to choose what is right for your project. So the moment you have a good, let's say, access, your precast would work. The moment in the projects where you can't deliver your concrete to that distance, probably monolithic instead of monolithic, the precast would be a better option. So some awards we have received. And we have also been recognized as one of the leading technology-based construction companies in India, one of the 8 companies. Thank you so much for being such a wonderful audience. I would love to take your questions, if any.
Thank you, Bhavya, for a very wonderful presentation and the steps that you have taken up incrementally over the years to make sure that technology is not just limited to large cities. It can even come from a place like Mysuru, which people consider to be a very small place, but the latest of technologies has been presented by your family and has gone all over India. We're very proud of you. Youngsters, you have any questions for Bhavya?
All are youngsters.
In their own way.
At least by brain. Sure, on a lighter note, is Somshekhar here?
Yes.
You are the luckiest, sir. You've got some.
No,
5 years we are doing the
replaced.
same job.
Let me
Nobody has
you
replied.
can't be replaced.
No. 25 years we're doing
It's very difficult to have the energy and the cadretness you guys have. So.
anchoring we are doing, nobody to take over from us. That's what we say.
Retirement for us.
You need
You
to
are
start
lucky,
training
sir.
someone.
So, you have got one question. So, Professor R.V. Rangnath has a question.
All are youngsters, sir.
Excellent presentation.
Thank you, sir.
I like the idea of knockdown.
At the last, yeah. That's,
So, what time frame you are thinking when you are designing? Is it knockdown after a couple of months for a
2 years.
construction?
3 to 4 years. 5 years.
So, what are the damages you have to see? Let's say when I have to knock down after 10 years, what are the likely things I'm going to lose when I knock down? Am I going to get the whole structure as is, or is there will be some loss?
Your
Just,
whole,
again, I don't know.
got it. Yeah, I hope I'll do justice for your question. So the whole structural elements, including your foundation, is knocked down in there, and there'll be absolutely no grout or any wet, non-shrink grout, anything which is being joining. It's only going to be a flexible sealant which is easily removable, and there'll be no tiling also that we will be doing here, because we want to make it knocked down, where we are utilizing the kind of surface that we are already getting, probably with a transparent varnish to seal the entire surface. And yeah, that's about it. A floor coating and a wall coating. So of course your block work or your yes.
Mike Kodapalli.
Congratulations, Bhavya. It's been a wonderful presentation.
Thank you.
Just to get an idea about the costing for the benefit of others,
Right.
what was the costing you arrived at on these knockdown ones or for the other buildings which you did?
Knockdown is definitely, I would say 5 to 7% expensive than your regular precast. Only because the kind of connections that we create, and also these connections are for many years to live. So we want a solid connection there. Yeah, that is 5% expensive.
Just I wanted to add one thing only, not add, I ask, what is the curing system? Because you are doing self-completing, why not think about self-curing also? So how you are doing curing now at present?
Okay. Self-curing.
And you can think about a self-curing system also, a concrete itself which is self-curing also. That's what I wanted to add. Thank you.
So we haven't done self-curing here. It's mostly, chemical curing. As soon as we de-shutter, we just apply the curing compound, membrane curing.
The curing compound.
That is what we have done. The self-curing also affects my early strength.
No, I will tell you, self-curing you have done lot of work. No, there are two ways of self-curing. One is, adding something into the concrete, that we have done lot, but in SRM as well as SCRC. And second is the concrete itself can be designed to be self-curing, not based on the potent cement, it can be based on geopolymers. So
Okay.
self-curing with this system will be assured of the, even whatever curing you are thinking. Now curing is
Okay.
separate phenomena, so you may
Yes.
save a lot of water also there because you are using water for the curing. That's what my idea.
Okay.
So it will become more eco-friendly. Thank you.
Yeah. Thank you.
So Bhavya, thank you very much. I would like to call upon one last question, quickly. Yes.
Regarding this knockdown construction only, since you are not doing any grouting, how the integrity is built, and what about the earthquake resistance property?
Sorry, can you come again?
For the joints, you are not doing a grouting.
No.
You are doing only sealant and nut and bolt system.
Yeah.
How the integrity is built between the members, and what is the earthquake resistance property? How you are going to achieve that?
So yes, this structure completely what we have taken here also. Yes, of course we are not grouting it to make it behave monolithically, but these are nut and bolt junctions, and it is also for a low rise that we are doing where the impact is not so huge. Right? I wouldn't recommend this for a high rise structure. Right? But a lot of this itself is another solution for a lot of G plus 1 or 2 structures that we have where we want to move the structure. Yeah. I would say I think I will have to check that with my designer, but of course the bolted connections are designed keeping that in mind for G plus 1. Yes.
Thanks, Bhavya.
Hearty congratulations to you, Bhavya. Since from I was waiting, any lady will come forward. As per the date, 13th and 14th, a teenager will be seen. She has presented the case, and though I am a youngest or the senior most, I don't feel that I am a teenager also after listening to even this presentation and all. You have maintained the time and all. Whenever a lady goes to the dais also, so many questions will arise. That it is not nowadays. Ever since, if a lady goes there, plenty of questions rush to the mind.
But our construction industry has been quite
Even
generous
that
on
you are
it.
able to respond to it, that is
Thank
really
you.
I like it.
Thank you so much.
All the best as per your name. You have done a
Everything thanks to my
Bhavya.
dad, and he's been the one who has brought me here. To this
No,
extent.
whatever may
I'm nothing without
be,
him.
parents have given good support to you. I am with you. Continue like this.
Thank you, thank you.
Thank you. May I request Dr. M.S. Sudarshan, please, to chairman of the technical committee, to please present a memento to Bhavya and Shri Somshekar, Engineer Somshekar, Ravindranath and Girish to please join.
Thank you so much. Thank you.
Thank you. And now the important, very exciting panel discussion is going to come up.